Another challenge today, remove duplicates from sorted array. Well, just like you need to remove some unnecessary people from your life. Okay, anyways, let's get started. Let's see if we can remove some duplicates. Given an array, an integer array nums sorted in a non-decreasing order, remove the duplicates. By the way, excuse my it's too hot here, so I have to take off my clothes. Remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. So, since it is impossible to change the length of the array in some languages, you must instead have the result to be placed in the first part of the array. More formally, if there are k elements after removing the duplicates, then the first k element of nums should hold the final result. It does not matter where you leave beyond the first, okay? Return k after placing the final result in the first k slots of sums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. The judge will test your solution with the following. So you have input array and expected nums, and we put this array through this method, and then we got the expected length of the expected nums, and then we'll compare number one by one. If the passable, well, that's nice that at least they tell you how they're going to test it this time. So example 1, we have 1, 1, 2, output should be 2, and then 1, 2. Explain your function should return k equals to 2 with the first two elements of nums being 1 and 2 respectively. It does not matter what you leave beyond the return k, hence they're underscores. So this can be anything. Let's look at this. 0, 0, 1, 1, 1, 2, 2, 2. And we have 0, 1, 2, 3, 4. Okay. Your function must return k equal to 5, with the first 5 elements of sum being 0, 1, 2, 3, and 4 respectively. It does not matter whether you leave beyond or return k. Okay. Alright. So let's calculate the constraints. The length is between 0 to 3 to the power of 10. 3 times 10 to the power of 4. Negative 11, negative 100, less than. So the range is in between negative 100 and 100. So this is not very restricting. This is not very super restricting too. I mean, neither these will affect any specific, at least for Swift, syntax. So nums is sorted in non-decreasing order. Okay, so pretty much, well, this is an easy question. So pretty much because it's sorted in a non-decreasing, because it's sorted in a non-decreasing order, so we can pretty much just check if so we don't have to worry about if there will be a situation like 1 1 2 2 1 1, right? So because it will be always increasing, so we only need to consider the borders of the numbers, of the identical numbers. So 1 1 2 2 3 3 3 3 4. We just need to increase the counter whenever we reach the border of two identical numbers, two groups of identical numbers. Okay, so first of all, I think because we will always compare the borders, we will compare the current element to the previous element, right? So in order, this is like a deduction, right? Induction. So in order to start this induction, we need to first set up the base, and the base is that, well, the first element of the array is valid. So first of all, if this array does not have any element, then we'll just return 0. So by the way, if you're a Swift developer, this is one thing to note: the in-out operation. We don't usually encounter this in real life development, but this is interesting to see that this operator, or this, how do you call this symbol, enables you to modify the array in place. I'm going to move the camera here so that I can see the time. Wait, why is it? Okay, so okay, so first of all, let's do count. If count is equal to 0, then, well, return 0. Let's put a parentheses around the statement so that it's better coding habits. Okay, so now we have the first element. We make sure that this array at least have one element in it. So we'll start from the second element, which index will be 1, right? So k is equal to 1, and then for index in 1, nums dot count. Okay, so for every element in this array from the second element, if, let's say, if nums index is not equal to nums index minus 1, so that means we have reached the border, then we will move this number forward to the forward of the to ahead to the beginning. Okay, so we'll do nums k is equal to nums index. Okay, and then k will increase by 1. Okay, okay, and after this, at the end, we'll return k. Okay, so we have 6 minutes. Let's just go through. So for example, 1, 2, 3. K is 1, so we start with 1. Nums index will be 1, will be 2, and 2 is not equal to 1. So index is 1, it will be assigned to 1, so which doesn't change, and k increases. And we move on to the next index. Still not the same, assign. So okay, 1, 2, 3, it works. And what about 1, 2, 2, 3? And okay, so when we reach index 1, 0, 1, 2, 0, 2. So when we reach 2, so nums 2 is equal to nums 1. I'm talking about this scenario here. 1, 2, 2, 3. Okay, so we will do nothing. Skip to the next one. So k is still here. K is still here. And then when we reach, okay, I think it's good. Let's see. Hopefully I can finish this. Okay, correct. Yep. Okay, let's submit it. Accept it. Okay, perfect. We beat 41%. Wait, really? How much faster can you go? Like, oh, now I'm 94%. Okay. Yes, 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 94%. I know it's kind of random. This is stupid. Anyways, so highlight of this, I think it's interesting of this operation in out. So this is interesting. And other than that, I think everything else is pretty straightforward. But if you have a better solution or if you have any suggestion, please feel free to comment below, and I'll see you in the next coding video.